So let me piggyback on your description of the leaky gut, the structures themselves. One thing that's important to note for people is that your digestive tract is a tube, right? It's a tube that's open on both ends. So in fact, when things are in your digestive tract, they're still considered to be outside of your body. They're not in your body yet. When things are considered to be in your body is when they go through the lining of that tube and then they enter the circulation. The circulation, there's a layer called the basolateral circulation of the lamina propria, which is the inside part, the first inside part of your body, and then if it goes past that, it's entering your circulation. So the tube in your system that starts at the opening in the mouth and the upper respiratory tract, and then ends with the opening in the anal cavity is all still outside of the body, right? So I have a diagram here I can use to show that hopefully will help people understand, right? So you look at, this is what a healthy gut should kind of look like. This is a thick mucosal layer that is sitting on top of the intestinal epithelium of this is the lining,
Oh, perfect.
the
I love
intestinal
that.
cells, right? Yeah.
Okay.
So this part is the lamina propria, which is the inside part of your body. The tube would be up here. So if you think about your tube, the lumen is the hole in the tube. That's up here, right? So this is the mucosal layer. There's two distinct areas of the mucosal layer, mucin 1 and mucin 2. And then this is the single cell layer that acts as the final barrier between things entering into your inside part of your body. So when food comes in, it all enters in this top part. It's called a lumen. And so most of the microbes that live in your gut live in this top part of the mucus layer called the mucin 1 layer. And food comes in, it gets digested in this layer. The bacteria break it down to a certain degree. Your enzymes and all are secreted up here and it gets broken down. And then food particles are supposed to be able to move through. And when they get to the intestinal lining, the cells, the space in between the cells are supposed to be able to open up. The things that control that space are called the tight junction proteins. So they're supposed to be able to open up to allow certain nutrients in. Now, other nutrients like fat, like dietary fats and fat-soluble nutrients will get picked up from this digesting area and brought through using shuttles, like they're called chylomicrons or lipid rafts, for example. So your body will produce these little rafts that go across. They'll pick up the nutrients and shuttle them across the lining.
That's so cool.
Right? So yeah, there's all these transport mechanisms. Now, lots of vitamins like vitamin K27, for example, have specific transport mechanisms. They have receptors that they'll bind onto the cell layer. And when they bind to the cell layer, then carriers will come up, grab them from the cell lining and take them to the liver where they can get processed and used and so on, right? So there's a lot of active transportation going on. And as Bridget mentioned, the microvilli, the little finger-like projections, add surface area to the digestive tract so that you have lots of surface area to absorb nutrients and so on. Now, one of the characteristics of malabsorption is when you start losing these finger-like projections, when they go from this down to getting flattened. The scientific term for that is called enteropathy, right? So when your gut is damaged over and over again, like in the case of celiac disease or people with severe gluten intolerances, their gut or HIV, for example, or other gut infections or inflammatory bowel disease, all of these things that damage the gut lining, you get those finger-like projections shortening and shortening over time. So you lose surface area to your digestive tract. And when you lose surface area, you have less area by which nutrients can be absorbed. So you already have malabsorption, right? So that's one of the things. The other thing that occurs is that if these tight junctions remain open too much, you get a flooding in of things that aren't supposed to be in there, which triggers an inflammatory immune response in this area. That inflammatory immune response will damage these cells over time, which then creates a significant loss of barrier. And when you have these cells damaged, and things just kind of leak through non-specifically on a regular basis. Another area that gets compromised is there is a polarity difference between this part of the gut lining and this part of the gut lining, right? There's an osmolarity gradient. So that gradient, that change in concentration of solubles, actually facilitates the movement of certain nutrients through these cells. So that's called a transcellular pathway. The movement in between the cells are called the paracellular pathway. So larger molecules of nutrients will move in between the cells. Smaller molecules, like certain types of vitamins and minerals and all that, will move through these cells. When your gut lining is damaged, you lose that osmolarity gradient, and those nutrients cannot end up moving through the cell because they count on the difference in concentration from one side to the other in order to move through. So lots of things within the ability to absorb nutrients get heavily compromised when your gut is leaky and damaged, right? Now, the other part that's significant about leaky gut is this mucus layer. So as you can see in this diagram, we show most of the bacteria up here, right? In this liquidy, thinner version layer of the mucus layer. This inside part, as you see, there's not a whole lot of bacteria in there. The reason for that is this inner part is far more sterile than the outer part. It's a thicker layer. It acts more like a jello almost, rather than kind of a syrupy layer. And so it acts as a physical barrier to your good normal bacteria from entering too close to the cell line, to this intestinal cell line. Because the thing is, your body freaks out when you get too many microbes moving into this inside space, because your body thinks you're going to go into a blood infection or sepsis, right? That there's going to be a flood of microbes entering into your system and you're going to get infected in your blood. And so anytime this layer gets compromised, gets eaten away, and you get too many of your own commensal microbes moving into this layer, you're going to start triggering lots of inflammatory response constantly in this region. And that completely compromises nutrient absorption. It damages all of these cells. It prevents this layer from getting repaired efficiently. And it causes immune dysfunction in your body, because everything that enters this area, food particles, environmental particles, and all that, get an immune response, which means that your gut is then training the rest of your immune system anytime it sees those particles to elicit an inflammatory immune response, right? So that compromising is really important. This is kind of what it looks like when everything goes nuts, right? You get an eating away at this inner layer. Yeah, you get a translocation of all of those bacteria, viruses, protozoa, all kinds of stuff to the inner part. Because they're now in the inner part, you get recruitment of innate immune cells, which cause an inflammatory response, which eventually just breaks up and kills off these inner lining cells, right? So now this gut is completely leaky, meaning things are just leaking through, entering into circulation all the time. And this is a disease condition. Now, this can occur when you're 14 years old, 15 years old. It can occur in certain sections of the bowel and you may never notice it, but it continues to progress. Imagine all of these adjacent areas start to look like this, right? Then by the time you're 30, you've got a significant amount of your intestinal length looking like this. Then all of a sudden you start experiencing metabolic issues, allergies, food sensitivities, autoimmune disease, mood disorders, all of these things that are a result of this. So hopefully that helped kind of explain how things go.